Hello John, this is Schwabik speaking. I decided to make a video for you to understand the problem. So let me just open this project here. This is your original project, which was solved. You said 150 iterations. Well, honestly, probably somewhere after 80 iterations you can stop that. At least that was my findings. But let's see. Okay, so here we have the project. The truth is that when I put a path line there, somewhere here, say, it does show a weird pattern, like that the flow is rotating or something. There is a spiral path line. So there is apparently something not very real. It must be quite artificial. And you can also see that when I'm moving here, the velocity direction really is pointing in the direction of the path line. So this is not artificial, it really exists, right? We may also see that when we look at the pressure on the main grid, because when you do a pressure and you use local limits, you put here, say, 15, we'll see that something is really happening here in this channel, because we would expect isobars to be perpendicular to the channel here in this position. So something's really wrong. And we can see what's wrong also when we do a 2D cut. Basically, if I move the 2D cut somewhere like here, that's too much, somewhere like here, and I clip all the grids, I can make it real. Now I'm making it real because I want to see the velocity arrows, the markers. If you look at the markers, they apparently indicate the twisting pattern, the rotation. And what we see, what is very surprising, is that the axis is not having flow which is straight, but there is some component which is going upwards. So that's probably wrong. And we can expect that this is the axis what is making it. So this is not the problem of Babushka Brezi not having degrees of freedom or something. This is really linked to the axis boundary, okay? So now we need to investigate that boundary in detail. For that reason, we can just convert this Rhino and Cortex mesh into a basic grid. All right, and when this is done, we can just erase these two grids too. And now we should put the boundary node. We can do a browse operation, and we can browse the nodes. Now we see all the boundary nodes, and when we do operation investigating the nodes, we can see that some of them, like this one, is not having exactly coordinate x0, but they have a slight negative. This one is minus 0.0006, and for sure if we go to other points, we will see somewhere here that some of them are even more in minus x coordinate. So that is the reason why the solution is wrong. In fact, why this is happening? These axes assume it is a planar boundary. Now, that means that it takes the first phase it finds, and from that phase calculates the normal. Now, it doesn't need to be aligned with x, y, or z direction, so that's why it needs to take the normal from one of those planes, but it's random. But when they are not, when the first one is really non-planar, the other ones simply get that normal. And you know, on that very long distance, it can happen that if even a small mistake in an angle of that normal can produce a very different um, velocities, because this is like having artificial input, right? And that's also what was twisting the axis boundary and causing the flow to come from the bottom up. Now, how to correct this? First, of course, we should write some automatic fix, but I always check what is the nearest point, and I can expect that this row of points is probably the nearest ones. Let's see what is the coordinate. This one is only the x is minus 0.03, right? So I'm sure that probably there is not any point nearer than 0.01 to the axis. If it's nearer than 0.01, that's probably supposed to be an axis. So that's why we have here a command align. So I can align entities. Now, to which axis? This is very important because the command is dangerous. We want to align to YZ axis, right? So we just say align YZ. And now I don't put 0.03, that would be too risky, but I can put 0.01. This is 0.01 to this direction and 0.01 to that direction. So our nearest point is 0.03 minus, so that is less. So this point remains, but these ones which are like minus 0.006 will be aligned. So when you click, well, this is dangerous because if you put 1 here, you will align all these nodes into a plane, and of course you collapse brick. So be careful on that. That's why you need to know your dimensions. And when you click align, it will simply align your axis points. And then the only thing you need to do is run the solution, and you should be okay, right? All right, so the command is finished, and we can simply convert the basic 3D into a float 3D mesh and do a test. It will still complain about babushka Brezi, but then we can solve. Okay, we converted. I do test. And he complains about babushka Brezi. We say next one. We don't have any more problems. We hit solve, and that's it. I'll have the project already solved, so I will not save this. I have it in here in the support corrected, which I will send you. All right, so now it's imported. I can just say no points, we don't need them. And this is already solved project. First thing we can look at is pressure. I use local limits again. That's the nice perpendicular pattern we were expecting, right? So this solution looks good from the point of view of pressure. When we put velocity magnitude back, we can put also the 2D cut and show the velocity magnitude on the real cut. Plus we can see the markers, and now they're going straight perpendicular as we would expect. So that means that we probably don't have any more problems with the path lines, but we can check them. And now we can see that the path lines are going straight through as we were expecting. When we look at the velocity direction, we see that it's very straight. So now I think this problem has been solved. Okay, that's all for now. Good luck with solving the project. By the way, very nice project. I'll check this. Bye-bye.